9.4 is all about pyramids and cones. The volume of a pyramid is very similar to the volume of a prism. So I feel like if you can do the volume of a prism, you could easily do the volume of the pyramid. All you have to remember is that the formula is 1/3 base times height, where once again, the capital B is representing the area of the base, and that will vary depending on what the shape of the base is. And H, once again, is the height of the pyramid. And this will actually be, as opposed to base, since there's only one base, this is actually going to be apex to base. And apex, by the way, is just that tippy top point on a pyramid where all of the triangles meet. Okay, so let's go ahead and take a look at some examples. Example 1 is for a rectangular pyramid. It's considered to be rectangular because the bottom is the shape of a rectangle. We can see that the two sides don't match, so that's why it's going to be a rectangle in this case. And we're going to find the area of the base first, just as we did with the prisms. Since the base is a rectangle, we're going to use length times width or base times height, whatever formula you prefer. In this case, our length and the width are given for our rectangular base as 4 and 6. So all we have to do is multiply those two numbers, giving us a base area of 24. The height of our pyramid is going to be the perpendicular length from our apex, which is right here in purple, perpendicular to the base. So it's actually going to be this vertical length, which is going to be 8. So this is also given to us. So we have our base area and our height of our pyramid. To find the volume, it's going to be 1/2 base area times the height. And I like the fact that these formulas are so closely related to the prism and cylinder formulas, because all I personally memorize is 1/3 times those formulas, or 1/3 of a prism, or 1/3 of a cylinder. So, plugging in the values, we have 1/3 of 24 times 8. So 1/3 of 24 is actually going to be, 8, and 8 times 8 gives us a total volume of 64. This is a volume, so our unit is cubic, and it would be centimeters cubed. All right, let's look at one more pyramid. This time we have a triangular pyramid because our base is a triangle. And to find the base area, we're going to use the formula for a triangle, 1/2 base times height. And once again, when we're talking about the base and the height, we're talking about the base and the height of the triangle only. So I'm only focusing on this triangle shape. Since this is a right angle, I know that this triangle has a nice base and height already given, 5 and 3. So I'm going to use those as my base and height. So 1/2 of 5 times 3, let's see, 5 times 3 is 15. Half of that would be 7.5, or 7.5. So that's my base area. And my height of my pyramid is 8. It's given to us in the picture, as you can see, the length from the apex to the triangle at the bottom. And my volume formula is 1/2 capital B times H, so all I have to do is plug in these values to get my final answer. So 1/3 times 7.5 times the height, 8. So if you multiply these values, you actually get a very nice number. You're going to get 20. And as always, volume is cubic units, so centimeters cubed. So not too bad. And as you can see, it's very closely related to a prism. Okay, so volume of a cone, we would expect to be very similar to our volume of a cylinder. And it is. The formula is also 1/3 base times height, but just like with the cylinder, The cone we can rewrite specifically because the base is always a circle. So plugging in our area of a circle, pi r squared, we get the more straightforward formula of 1/3 pi r squared h. And this is the formula that I tend to focus on when I'm doing cones as opposed to the 1/3 base times height. Okay, so let's go ahead and solve our example 1 for our cones. So we need our radius and our height, and it looks like our radius is going to be 6, since our diameter was given to us as 12. And the height of a cone will be the vertical length from the circle to the top, which it looks like is 4. And this will allow me to plug these values into my volume formula, 1/3 pi r squared h. So here I have all of the values. All right, calculating. Let's see here. 6 squared is 36. 1/3 of 36 is 12, and 12 times 4 would give me a value of 48. I did not use the pi, so I have to tack it back on, and this would be my exact answer, 48 pi. And of course, centimeters cubed. If you prefer decimal, we could absolutely do that. So 48 times our pi gives us a decimal equivalent of 150.80 if you round. And that would be centimeters cubed as well. Okay, so one more problem. So these don't seem to be too bad. Number 2, we also have a cone. Our radius is given as 5, awesome. However, our height, is unknown. So we actually have to solve for our height. And we're going to do this using one of our 3 methods: special right triangles, Pythagorean theorem, or trig. If you look for a triangle that involves the height, you should be able to see this triangle here that I'm tracing out in purple. This triangle, we have the hypotenuse, 13, and we have the short side, 5. We're just looking for the height. Since we know 2 sides and we need to know the third, this leads me to the Pythagorean theorem. Our a squared plus b squared equals c squared. The hypotenuse is the most important side to plug in, correct? And that would be our 13, since it's across from our right triangle, or right angle, rather. This leaves our 5 and our h as our a and b. Again, order doesn't matter. And now we can solve for h. 5 squared is 25. 13 squared is 169. Subtract 25. And we get h squared equals 144. Get rid of the square by taking a square root. And the square root of 144 is 12. Once again, I ignored the negative square root because we are looking for a length, and in geometry it doesn't make sense to have a negative length. So it looks like our height is 12. We now have our radius and our height, so we're ready to calculate our volume of our cone. 1/3 pi r squared h. Here we go. 1/3 pi, 5 squared times 12. Okay, so I'm actually going to do 12 divided by 3 since it's divisible by 3. 12 divided by 3 is 4, and 5 squared is 25. 25 times that 4 gives me 100, and tacking on the pi, we get 100 pi as our exact answer. And yes, centimeters cubed. Or as a decimal, we have 314.16 if you round. Centimeters cubed. And there's our final answer. So notice pyramids and cones are closely related to prisms and cylinders, except we have a 1/3 in front of each of the formulas. And keep in mind that you still may need to find those right triangles using Pythagorean theorem, trig, or special right triangles to find one of the missing components. Also, I did not show you a regular polygon in this section, but you could also have a regular polygon with a pyramid as well, so please keep that in mind.